discussed whether midget was an appropriate word to use. That was our big conversations in class today. And the answer to that question is no, just in case you're wondering. Not okay to use that word. You should say a little person or dwarf. No, it's offensive. Did you ever watch that show Little People Big World with the roll-offs? They did not like that word. It was offensive. And they had the LPA, the Little People Association, because that's what they went to the little thing, and they didn't call it the Midget Association.
I find that dwarf is pretty offensive.
But dwarfism is like the actual genetic disorder, though. Like, they are dwarfs because they have a form of dwarfism. Like, they say they would rather, they want little people is what they want to be called. But then dwarf is better, and then midget is not okay. Midget is like offensive. They do, though, I promise. Okay, now I don't know, I can't speak for every little person, but the ones I've seen on TV prefer little people. And I heard one on the radio, too, and he said that little people is the best, and that they're actually, like, the people on Little People Built Big World were actually, they had a form of dwarfism, so he said that they are okay to be called dwarfs. But the definition of a midget is really just anyone, like, it's just like a short person. Like, if you're under like 5 foot tall, like, then you're considered a midget. But when you think of midget that you say, you're thinking of a dwarf that you should call a little person. It's just not appropriate. Like, if you saw someone walking down the street and you just said, hey, look, there's a midget, they're very offended by it. So don't say it.
Of adult midgets, I think of little person, I just think of like a child.
Little people. That's what they want to be called. I'm educating you today on the little people of America. I'm a spokesman. Not really. This got all started because Cora started talking about it. I don't know why, but she used the M word that I'm not going to say anymore because it's offensive. The M word, you know.
I was like, wait, we changed.
We should say little people, not the M word. Probably shouldn't say the N word either. Just throwing that out there as well. Population model, right here, where P sub 0 is the initial population. Notice it's very similar to just the initial amount that we talked about in our other form of the equation. R is the percentage rate that it's increasing or decreasing. So they usually give it to you as a percentage, but in your formula, you always want to change that percentage to a decimal. And T is usually your time in years unless it specifies differently in the formula. And so part of your homework today is just working with this equation, saying is it growth or decay, and what is the rate of increase or decrease. And then another part of your homework is they give you that information, they want you to write the equation. Someone in second hour pointed out that this is very similar to like an interest formula that maybe you learned last year, where P was like the principal amount of money, R was your interest rate divided by the number of times interest was compounded. And I said, oh yeah, I never really thought about that it's very similar, but it is. So I think we should just do a problem. You're okay with that? Everybody okay with that? So tell whether each function is exponential growth or decay, and find the constant percentage rate of growth or decay. We did this yesterday. Is it growth or is it decay? I feel like with population, it's easier, like they don't trick you with all those negative exponents. So I'm just going to write that formula right under here just so we can look at it again. Population is P sub 0 times 1 plus R to the T power. So the first one here says 3.5 times 1.09 to the T power. If you think about this as writing it as 1 plus R to the T power, maybe we could figure out what R is first before we decide if it's growth or decay. What would my percentage rate be in number 1 here? 9%? Do you agree with him? So this would be like 1 plus 0.09 as a decimal. To get it back to a percent, you move it over 2 places. So we could say that the percentage rate is 9%. Is that population growing or getting smaller? it's growing, and we talked about this yesterday. If this is bigger than 1, it's going to be a growth model. It's going to be getting bigger. If it's smaller than 1, it's going to be decaying. So we could say that this is exponential growth, and it is growing by 9% every year. 9% growth, I could say. Follow me on that? So same idea with the second one here. If I said 43 times 0.05 to the t power, would that one be growth or decay? Decay, because this is smaller than 1. Everybody with him on that? I could say this is exponential decay. And think about what would r have to be if it's 1 plus r. What would r have to be so that I would just have 0.05 in that? It would have to be negative what? Negative 0.95. Or what percentage would that be? And in the book, I'm okay if you say negative 95. In the book, they say 95% decay. And so instead of saying a negative, they put the word decay after it. But I'm okay if you said negative 95.
The 1.09 number 1 is
Which part? The growth or decay or the r part? Or all of it?
well, I was writing and then I number 1.
We were trying to figure out what r was, and every time this is our formula, 1 plus r, right? So if this is 1.09, it's kind of like you're saying 1 plus r had to equal 1.09. So to figure out what r was, can you just subtract 1 from this? That would give you your rate every time.
Yeah. Oh, okay. I get it.
Because this is 1 plus r. So if it's 1.09, I already have the 1 there, so that means r had to be 0.09, which is your decimal of your rate, so I just changed it to percentage. How do we know whether it's growth or decay? It's the same as yesterday. If this is bigger than 1, it's always growth, and if it's smaller than 1, it's always decay. Does that make more sense? Maddie?
I don't understand why 0.09 is 9%, but 0.05 is 5%.
Because you had to do the 1 plus r, right? The formula is 1 plus r to the t power. If it's 1.09 is what that equals, then to solve for r, you would subtract 1, and that's where I got the 0.9, because it was growth, so you can kind of just tell that it's 0.9. But in the second one, r is negative, so it's not just 0.05. This is still my formula. So it's like 1 plus r equals 0.05. You have to solve for r. So you have to subtract 1 over, or you have to think about what would I add to 1 that would equal 0.05. And when I take 0.05 minus 1, that's where I get the negative 0.95. Right? R is not, this is not r. This is the formula 1 plus r. So you have to solve for r every time. If r is positive, you're right. It's just going to be whatever the extra decimal is. But if r is negative, you have to think about that it had to be a negative number and subtract from 1. Does that make more sense? Population 2 is not looking so good because it's decaying 95% every year, which means they're not going to live so long. Nobody likes to really think about that sort of thing. But bacteria. We like to talk about bacteria stuff. It's okay for them to die, right? Okay, what if I go the other way? What if I give you an initial value and I give you a percent increase or decrease? I want you to be able to write the equation. And again, this is where you have to know the formula. On your homework today, it's great because you have the formula. On a test, you would have to make sure that you know if I gave you a value about population. Again, I'm going to write it again. It's the initial population times 1 plus r to the t power So you're just plugging the value. They're giving you initial value. They're telling you that it's increasing at 17% per year. Just remember that whether you're adding or subtracting R there matters. So for this one, I would say my initial value is 5 times 1 plus R, and what am I going to write as R? 0.17 to the t power. And probably you're not even going to write that on your paper because you're going to go ahead and add that up in your head, which I'm okay with. 1.17 to the t power. And you should be able to check there. That's definitely growth. It's growing or increasing 17% per year because that is bigger than 1. With me on that? About the second one. If I have a population of 28,900 and it's decreasing at a rate of 2.6 per year, notice they're not telling you that R is negative. By giving you a negative rate, they're giving you the word decreasing. So you have to make sure that you know that means that you're subtracting R instead of adding R. So again, my initial value is 28,900. But now I'm going to subtract 2.6%. So don't forget that's moving back 2 places. So that's like 0.026. Right? And you could just take 1 minus 0.026. Nick, what do you get? 0.974 to the t power. So when you have a decay function, when the population is getting smaller, your base there will always be less than 1. Questions about that? The rest of your homework has to do with solving a problem about population or maybe exponential decay. So we can do this just like we did yesterday, where you could just guess and check, but I want to show you how we can use the calculators to help us do this as well. So I'm going to show you the next one where you can write it out, and then I'll pass calculators out, and we'll kind of talk about it. Okay? So here we go. You don't have to write every word of this, but same thing, you should still be able to write your equation. They're giving you the population of Jacksonville, Florida in 2000 was 736,000 people, and it was increasing at a rate of 1.49%. At that rate, when will the population be 1 million? And so, besides that last sentence, step 1 is write your equation just like we did last one. So you write your equation, and then I'll see if we can have some calculators. So Bryce, you think you can tell me the equation for this population of Jacksonville, Florida?
Check that.
I'll get you started.
736,000
Because that's your initial value.
times 1.0149.
1 plus the percentage rate, which would be 0.0149. So yeah, 1.0149 to the t power. I wasn't saying you weren't. I saw you were weak. That's why I called on you. Everybody agree with Bryce on that? We did this yesterday. We said, so when will the population be this much? And we just kept guessing numbers, right? We could do that again, but I want to show you how you can actually use a graph to help you find this. We want to know when this will be 1 million. So we want to graph this equation. Then we also want to graph the equation 1 million. So I'm going to graph the function 1,000,000. First of all, what does an equation look like when you graph just a single number like that? Like y equals a number. Straight across at 1,000,000, right? So when I graph these two, what I'm looking for is where they intersect. Where does this meet up with 1,000,000? And that's going to tell me my answer. And so I just want to show you how we can use a graphing calculator to help us. These are really big numbers, which means we have to change our window. Some people, you might have a calculator from second hour, so might have already changed their window. But step one is we're going to type our equation. You're still going to use x and y, even though this has a t up there. Yeah. Oh, children. Why are calculators so awful? Should I just put it back in? So we don't get the mistake. It's up here, so I just got it. I just disordered that for you. So let me go to my graph. And I'm going to type in 700. 736,000 times 1 point, was it 049? 0149? And then you just need to hit this caret button, and yours will keep the caret on there, but mine's fancier and it moves it up there. And then you just hit your X button up there. Caret's right here below clear. Like that's your exponent button. I don't know why we call that a caret, but. And then we're going to graph the other one, the 1,000,000. This 736,000 times 1.0149 to the t power, or x power, right? Because your graph only works with x's and y's, so even though we have a different letter, we're still using x. Yes? No? Maybe? So when you change a window, I've already changed my window, so I don't want you to just copy. I want you to think about this before you just copy down what I have up here, right? Because I wasn't thinking ahead of erasing this for second hour. But on my window, the x-axis represents the number of years since 2000, right? So I changed my x-axis to go from 0 to 100, which means, does it make sense that I wouldn't include any negative numbers for the x-axis? Because I'm not going to go before 2000, right? My population's getting bigger. And you really could go as big as you wanted here, but I just figured if it was already 736,000 in 2000, I probably wasn't going to have to go that far. I probably would have just went to 50, but in second hour, someone wanted to go to 100, so we went. This button, X scale, that's what your x-axis goes by. And so, like, probably yours might say 1 right now. That's okay. I just changed mine to 10, which means each mark on my graph is going to go by 10. So it's going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. You can change it to whatever you want. If you put it as 1, it just makes it really hard to see. And then my minimum and my maximum on my y-axis, that's my population. And so I started my population at 700,000. Could I have started my population at 0? Could have. Does it make sense to start my population at 0 on this problem? Because where did my population start that they gave me? Yeah, I started at 736,000. That was my initial value. So I said, why go to 0 when I have such big numbers? So I started up here at 700,000. And I needed to go to 1,000,000. Why do you think I plugged in a number bigger than 1,000,000 on my y maximum? So I could see where it crosses. Because if I just put 1,000,000 here, 1,000,000 would be the very top of my graph. And then I wouldn't be able to see for sure where they were intersecting. So you want to think about that. I think graphing calculators are great, but the number one reason people struggle with them is they don't know how to change their windows. And then notice my scale on this one. Because these are such big numbers, I could have made it go by 1 or even 100, but I made my y scale go by 100,000. So each mark represents like 700,000, 800,000, 900,000. And for every problem, you might have to go back and change your scale so that it matches the numbers that are in the problem. But if you type that in and you hit graph, you should get an exponential graph and a straight line, something like this. And if you ever get an error that says window range or window domain, that means you've messed up something on your window. So that's my population at 736,000 in 2000, and then it's just going up and up and up, and that's my 1 million mark right there. Anyone having issues getting that to graph? So we could just use our zoom and we could try to just zoom in here and get a pretty good guess, but your calculator will actually find a point of intersection for you. So I want to show you that, and then I'll write the steps down here if you need it. But under calc here, that's the button that we've used to find zeros and the button that we've used to find max and mins. That's an awesome button on your graphing calculator because it'll find you the x-intercepts, that's zeros, it'll find your minimums, it'll find your maximums. And look at number 5 here. It will find the intersection of 2 lines for you on the calculator as long as you have them graphed correctly. So if you hit number 5, it's going to ask you questions just like it does for max and mins and such. It wants to know which 2 lines are you talking about. If you only have 2 lines graphed, if you just hit enter, it'll just jump to both of them. So when it says first curve, I just hit enter, and then it jumps to the second curve, and I just hit enter again. Sometimes you might have like 4 things graphed, so that's what it asks you. And then just like everything, the program that's on these on these calculators, they want you to guess. And so I just use my cursor, and I'm just going to come over here and get pretty close. And I'm just going to guess there, and I'm going to hit enter. And it tells you when this graph equals 1 million. So if you want to write that down, you hit second trace, which actually gets you to calc. And then it asks you for the first curve, and you should just be able to hit enter. It asks you for the second curve, you should just be able to hit enter. And then it asks you to guess. And you actually should try to guess, don't put way far away. Scroll over, so I'm going to put scroll, and then hit enter. And that always works. The nice thing about this, as opposed to yesterday, we just got to the nearest year yesterday. We were like, that's 1970. We could be more accurate here, and we could say in about 20.73 years is when that occurs. And that was from 2000. So that would be sometime during 2020, right? We could even be super accurate if you wanted to be super nerdy. Could we change 0.73 years into months? And then we could even change that into days and hours and minutes if you really wanted to be that goofy. It's almost 20 years and 9 months. Yes. It's supposed to say guess, but I forgot my U, so I tried to shove it in there. Yes. That's what it asked after that. I have another one here about exponential decay, just because it is different to write the equation, and then I'm going to let you work on your homework, okay? So let's look at one more, see if we can shorten this up on the writing part. So the answer here was, at when will the population be 1 million? At about 20.73 years. Let's shorten this up if you're writing this down. Instead of writing supposed half-life, let's write half-life 20 days. And then write 5 grams initially. That shortens that whole first sentence, and then start there with find. You should write that second sentence. So you kind of shorten these up sometimes. So the half-life of a certain radioactive substance is 20 days, and there are 5 grams present initially. Find the time when there will be 1 gram of this substance remaining. We're going to do a whole lot more half-lives later on in this chapter when we start solving the equations. But today we're just kind of working with some basic stuff here. So the hard part about this problem is being able to write your equation, because this does not fit that initial population 1 plus r to the c power, because We don't have an R in here. We just know the half-life. And remember what half-life means? It means that in 20 days, how much of my substance will be left? Half of it. That's the definition of half-life. So it's like decaying. So whatever the half-life is, in that amount of time, half of it decays away. So when we write this problem, we're still going to start with our initial value. So think about, let's go back to what we were doing yesterday, where we had like A times B to the X power. I really want to use T here, but that's right, I'll use X. Okay. That's like the go-to exponential function. What does A represent? The initial value. Do I know the initial value? Do I know how much was present initially? 5. So I could say y equals 5 times. And now here's why we're doing this problem, so that it will help you on your homework. When you're talking about a half-life, or you're talking about something half of it going away, you can make your base a half. If you were talking about something doubling in so much time, guess what your base would be? 2. If you're talking about something tripling, your base could be 3. So that's where that comes into. And then your exponent here is kind of a little tricky here. But think about when I plug 20 into this problem, I want to be able to just take 5 times 1/2. You with me on that? Because 20 days, half of it's going to go away. So in 20 days, I better get 2.5 out of that. So what if we wrote it as, I'm going to change it to t here, t over 20 as my exponent. If I plug 20 into that now, that's always going to work out that the half-life gives me half left. And that's always going to work for half-lives. That's your base, and whatever your half-life is going to be the bottom of that fraction. So there's one on your homework just like this, only the initial amount and the half-life's different. But that's why we're doing this one. And just like the last problem, we could just guess and check until we got 1 gram left, or we could graph this, and what would be the other equation that we graphed? Instead of 1 million, what do we want to be left? 1. And we want to see where those cross. But I want to look on the calculator for this one, because I want to remind you that when you type this in your calculator, you have to put this in parentheses, right? Your calculator only does what you tell it to do. And if you don't group together that as an exponent, it's not going to give you the right answer. And this is going to be an exponential decay problem, because that's less than 1. So let's see if we can go there and graph that. So 5 initially times 1/2, and notice I'm putting 1/2 in parentheses, because that's my base. All of it is my base. Someone in the second hour said, where's my fraction button? There is no fraction button on the graphing calculator. The division sign is your fraction button. And when you raise it to the power, your calculator shows you the caret, but mine doesn't. You have to put parentheses around that, or it's not going to take everything to the exponent. It's going to only take the first thing. So we're going to put x divided by, what was it, 20? If you don't put it in parentheses, you're not going to get the right graph. Then we're going to graph 1. Should I change my window from the 1 million that I had set? Yeah, we're kind of like going extremes. We had really, really big numbers. Now we have pretty small numbers. We're starting with 5 and we're ending with 1. That's my y values. X is the number of days. Could I leave that from 0 to 100? Does that seem reasonable? I think that's okay. So I'm talking about the number of days. I don't think it's going to be more than 100 days, but I could be wrong. We'll see. What about my minimum? So talking about the number of grams I have left. Eventually, if it's decaying, is it eventually going to get to 0 grams? It's going to get really, really close to 0. So I'm going to say my minimum is 0. And how much did I start with? You could go more than that if you want, but I'm just going to go with 5. And I don't think my scale should go by 100,000 anymore. I think I'm going to go by 1. See how this is really important, the window part? If you don't get the window right, your graph's not going to be there. But when you graph this, you should get an exponential decay model. That's exponential decay. and you should get 1 going across there. And if you do that intersection again, you should be able to tell me how many days did it take for it to go from 5 grams to 1 gram. If the half-life was 20 days, should your answer be bigger or smaller than 20 days? Bigger, because in 20 days there should be 2.5 grams left. That should be bigger than 20 days. Let's try it. Calc 5, enter, enter. That's a pretty good guess. 46.4 days. Again, you could be super nerdy and change that to hours. 46 days, so many hours. Or super cool. I don't know that nerdy has to be the word.
So we're in moving graphing calculators now.
Well, there's 3 problems on your homework. You can at least set them up, and then we can finish typing them in the calculator tomorrow.
Alright.
Okay? So you should be able to maybe get 1 of them done right now. This is it. On your homework, 30, 33, and 34 are the ones that are just like we just did, where if you want to graph them to find them, you can. So try to get at least number 30 done. And then tomorrow when you come in here, grab a calculator the first thing you do when you come in, and you can finish up the last 2. But have your equations already written. Like, all you should be needing to do tomorrow when you come in here is type them in. Or you could use another resource for calculators, but I'm okay with giving you time tomorrow to do it. Graphing calculator. So you have like 7 minutes right now, so open your books, start number 30. It's the big one, like the million one. So you can change your window back, or you can skip to the one that's half-life and do that one since your window is already changed to small numbers. But you should be able to get that first one done. And I know it's going to make your numbers out of order. If you're OCD, you might have to just write it down later and put it in order. But I'm okay if you start with 30, 33, 34, and then go back and do the other ones. I'm going to give you about 5 minutes tomorrow, so make sure you come in ready to type those in if you need more time for it. the whole year where it would be a million or whatever. I'm okay with that. Eventually, we're gonna learn how to do the algebra, where you have to like element both sides and do all that fun jazz that you might sort of remember. But you don't like you're not required that you have. There's a box up there for the graphing calculator. Just throw them in there.
FFA junior or seniors interested in attending camp, please see Ms. King today. FFA juniors or seniors interested in attending camp, please see Ms. King today.
What does Y represent? When you plug in so much time, what do you get out of it? What does it represent? If you plugged in 10 here, what would that represent? The number of that? It represents the population. Your population, you want to know when it equals a million. So that's where your y-axis is a really big number because you need your maximum transmission the minimum, you can start wherever you want. You can start at 0. You can't. But to me, this tells me it starts at 478,000. So I would start at 0 because that's kind of going to make your graph way bigger than it needs to be. You know what I'm saying? So like what would you
I need China Hagee and Robin Walls at Wyatt Meets the office, please. China Hagee, Robin Walls at Wyatt Meets the office, please.
It can be. So you could pick like 500,000. And then like you could pick a million, but that's what I said. Pick bigger than a million so you can see that on your graphic. And then hit graph.
Oh, I didn't use it.
That's what I figured. Let's go do this. I already did.
Okay.
So go back and watch right now. You guys did your homework. Why do you hate Mr. Stewart?
Whenever I'm doing the intersect, first curve I press enter. How do I do that?
Just press enter again. Because there's only 2 equations graphed, it'll jump from one curve.
Oh,
Do there you go.
mind if I just show up it?
That's fine. Okay.
Thank you. Yeah.
Could you be carrying any more books?
Oh yeah, I don't have my account. Oh yeah, I do. Never mind. Yes, Caleb.
Oh my gosh, I'm still recording.